25,000. Now this ratio over here, they have no units. What it means is that no units means same units. That is why we can remove the units. Now whether it is interpreted as 1 cm to 25,000 cm or 1 meter to 25,000 meters or 1 kilometers to 25,000 kilometers. It doesn't matter because they have the same units. So you have to be smart to choose the units you want to work with. Now in part A, they want it represented as 1 cm to a certain number of kilometers. So 1 cm to n kilometers. Therefore, it makes sense for us to work with the first ratio in centimeters. Okay, so on the left hand side, we keep it as 1 centimeters because on the right hand side, we want to change that to kilometers. So 25,000 centimeters, you divide it by 100, you get 250 meters. Continue dividing 1 cm to 0.25 kilometers. Now this is the working, but I need you to add on top what you are referring to. So this over here will be the map and actual. Okay, so everybody please look at the screen. No matter how you present it, okay, you probably have your own way of presenting it, but if you are using ratio like this, I need a header. And in this case, we are only dealing with the length. So whether you write length on the left hand side or not does not matter, because you're only dealing with length. Subsequently, part C, where we are dealing with area. Okay, we will use the same ratio. Now, map to actual. So I want everybody to look up now, regardless of whether you know how to do this or not, because I'm going through the presentation. In the first part, part A, we found that 1 centimeter for lengthwise, okay, let me just put it down here, 1 cm, is to 0.25 kilometers. Double check, 1 cm to 0.25 kilometers. Now this over here is a comparison of length. So you must put aside length. Okay? Now next part, area. We're going to compare the area given the ratio of length. And we do so by squaring the ratio of length. Because on the map, what is on the map and what is in reality? There are scale drawings, there are similar figures. So we have to square them. Now 1, you square 1, you still get 1. You square the centimeters, you get square centimeters. 0.25, we square that. Kilometers, you square, you get square kilometers. And now we have the ratio of area. Take note that the question in part C, they're talking about the area in square kilometers. That was why I chose to use the answer in part A, which was already a length in kilometers. I want to work with kilometers. And on the other side of the ratio, I've got centimeters because the question wanted it in square centimeters. So all I have to do is conveniently square everything. Okay, so I get a relationship between these two quantities, area and length. So from here on, 0.25, we square that. And we get 0.0625 square kilometers. Since they require the actual required area is 2.5 square kilometers, work backwards and find the corresponding area in square centimeters. Okay, presentation is important.
So,
yes.
will this question 1 mark? I thought we just answer mark.
Yes, you can just write the answer mark, but what if they give you 2 marks for that? Okay? We cannot be certain. Now in part, question 10, similar figures over here. We've got triangles, and they gave us 2 angles that are the same. So these two being the same, the reason is that it is given. Show that the triangles ABC and ACN are similar. 2 strategies. 1, you draw out both triangles in the same orientation. So for example, I will just highlight the big triangle, triangle ABC. So that as the name goes, A to B, then to C. So I will now draw the small triangle starting from A in the same orientation. So bottom left corner, A. Now the next letter is C. So I compare, where was my letter B? Oh, on the top right. So I'll put C over here. And finally, the last letter in the big triangle, that is C. So in the small triangle, there will be N. Okay, they correspond to each other in this manner. So C is to the right of A. Therefore, N must be to the right of A as well. So this is the orientation for the small triangle. Then based on this, we identify all the angles that are the same or corresponding. So we know that the small triangle, angle C, rather ACN. That is the given angle, ACN. Let's identify ACN over here. And we can tell straight away, for these two triangles, the topmost angle are the same. That is given. So by drawing it this way, I know I have to prove either this angle, angle A, is equal to this angle here because they are corresponding, or I have to prove that angle N is equal to angle C over here. So that is the advantage of drawing out the triangle, but that takes a little bit of time. The other strategy is to go solely by the names of these two triangles. They told you to prove that they are similar. Since they tell you to prove they are similar, you can be sure that they are similar. So we are going to make use of the hints from the names. First, it is given that these two angles are the same already. So let us find in a large triangle, angle B. Okay, angle B over here is known as angle ABC. So B is right smack in the center of A and C. So I say that angle ABC is equal to, let's check out the other angle that was given to be the same. This is angle C. Over here. Yes?
I thought, does the order of the letter matter when you write similar triangles?
When you write similar triangles, the order matters, but when you are calling out the angle, the name, the orient, okay. Whether you write ABC equals to ACN, or you write CBA equals to ACN, doesn't matter. But to keep things neat, we would want you to write down ABC instead of CBA. Because by writing it this way, we are keeping the first two letters, the first 2 points, the same. They are corresponding to each other. Whether it's from the small and the big triangle. Okay, so it is good practice to keep the order. But it is not necessary for writing down angles. However, when you are calling out the names of the triangles, it is necessary for you to follow the order. Okay? So that is one angle already. I know I need another angle. So based on these two names, I know that if I can prove that the first two angles are the same, A and A, then I'm done with my job. So let us take a look at inside the big triangle, where exactly is this angle A? So that will be given by BAC. So go according to the name, BAC. Angle over here. The other one, angle BAC. Go over to the small triangle. We started in the middle. One step to the left and one step to the right. What does this order represent as the angle? CAN. Okay, let's check. C to A to N. Hey, they are referring to the same angle. So this is still equals to angle CAN. According to the name. So the reason over here is that it is common angle. They are referring to the same angle A. Whether it is BAC from the big triangle or CAN from the small triangle. So since two angles are the same, we can use the AAA similarity test. Okay, but because I'm kiasu, say that the last angle that was not covered. Okay, I've already got angle B and angle A in the big triangle. I'm left with angle C. So I'm going to put C in the middle. Let's call it BCA. Angle BCA. equation C and A. C and A. I don't even bother looking at the diagram anymore because I'm sure it's going to be the same. And the reason is because angle sum of triangle. Okay, if two angles are the same, then the third angle must be the same in a triangle. Therefore, by the AAA similarity test, then we copy down whatever was given in the question. Triangle A, B, C is similar to triangle A, C, N. So that's the first part. Next part, they give you some lengths. This is a similar triangle question. So you can be sure that they're going to be dealing with ratio of sides. I'm going to make use of what was obtained, what was proven in part A. So I'm going to come up with the ratios. Okay? From the first triangle, okay, for either triangles we have three sides. We need to write down the corresponding sides as a ratio. So here we've got given that AN, NB, and AC. Definitely I want these to be inside my ratio. So let's start off with, let's have AN. Okay, AN is found in a smaller triangle. So AN, and its corresponding side will be AC. Okay, so we start off with the smaller triangle first. Let us continue with the small triangle. The next side, besides AN, we could use AC or we could use CN. So you have to make a choice. AC is going to be more useful because that's what they want in question. So let's use AC instead of AN. So the corresponding side will be over AB. Okay? You can go ahead and write down the last side, CN over BC, but I don't think it's going to be useful in your calculation. So from here, let us do some substitution. AN, that is 4. AC, we don't know that. It's fine. On the other side of the equation, we've got AC again. But it is the same unknown. Now over AB. AB is made of AN plus NB. So that is 4 and 5, giving us a total of 9. Therefore AC squared is 36. AC must be 6 or negative 6, rejected. Answer 6. Question 11. Okay, write down an angle and expression in terms of x for cosine p. You have to know this, that when you take cosine of an obtuse angle, whether you memorize or you understand, I don't care at this stage. You just make sure you are aware of how to do this. Cosine of an obtuse angle, so cosine p, is equal to negative cosine of 180 degrees minus p. You have to know this. So visually, you can remember it this way. I see a straight line. Okay, so that's an obtuse angle. If I want cosine of this angle, then the answer will be negative cosine of the adjacent angle on a straight line. Because that's what 180 degrees minus that angle means, adjacent angle on a straight line. You can draw the graph, the cosine graph, and use its symmetrical properties to understand why this is true. Okay, so moving on. Inside this 180 minus p, our result will be an acute angle. This over here, 180 degrees minus p. Cosine of this angle, turns out that this is a right angle. So cosine of this particular angle is adjacent over hypotenuse. So negative, copy the sign down, 4 over x. Done. Next, for part B, the area of the trapezium ABCD 5 times area of ADC. Trapezium. Area of a trapezium is given by the formula half times sum of parallel sides. So area ABCD half times the sum of the parallel sides, which is DC plus AB times the perpendicular height. In this case, it is AD. The area of the triangle they are telling us that the area of the trapezium is equal to 5 times that of the triangle. So let me just put down the area of the triangle in the same line. After I multiply by 5, DC times AD. Okay, so now this is what we have. Area ADC. Let us do simplification. We multiply by 2 on both sides, so the half disappears. We divide by AD on both sides, AD disappears. Now we have the value of DC, which is 4. So 4 plus AB equals to 5 times 4. Simplifying it, evaluating, we get AB equals to 16 units. So we're making use of the property that both the trapezium and this triangle, they have the same perpendicular height. Question 15. Radian question. You are all A-Math student. Radians should not scare you. So here we have AOB 2.5 radians. They did not write the degrees, they did not write any units, therefore it implies that it is in radian. So the area of the minor sector looks like this. Please note the difference between a sector and a segment. So the area of a sector has a formula, half r squared theta, where r will be the radius, which is 4, and theta is the angle in radian. It is conveniently given to us that it is 2.5. And that's as straightforward as it can get already. 10 times 2, 20 square centimeters.
So
yes?
segment is minus the triangle.
A segment will look like this.
It's no formula, right? It's just this one minus the triangle.
Yes. So write down an expression in terms of pi for the reflex angle AOB. So AOB, this is the obtuse angle. So this is the angle they require. If this were a question in degrees, and they tell you that, oh, this angle over here is 130 degrees, how would you find the reflex angle? Exactly, 360 minus, right? So you take one complete cycle minus away the angle that is already given. Now what is one complete cycle in radian? 2 pi. Therefore, the answer over here is 2 pi minus 2.5 in radian. 2 pi minus 2.5. Now find the length of the arc ACB. It has a formula also. So arc length equals to r theta. That's it. Radius, which is 4 again, times the angle. So 8 pi minus 10. Did they ask for, oh, they wanted it in terms of height. Therefore, the answer is 8 pi minus 10 centimeters. Let me just verify. What question is this? 15. Yep. Okay, next. Okay, question 17. I'll scroll down to the last question. State showing your reasoning whether AF is or is not parallel to BD. So please look out, everybody. I want to cover this question. Basically, I want to cover as many of the explanation questions as possible. You guys can calculate, but can you explain? Okay, so this is an explanation question. AF, BD. So here we have AF and BD. They appear to be parallel, but we cannot use that as a reason to conclude whether they are parallel or not. So to determine whether two lines are parallel, we're going to use the converse of some other properties that we know. What am I talking about? So we've got our angles over here. In the first, when we see the letter F, we are talking about corresponding angles, parallel lines. Okay, so to recap, angle A and angle B are the same if these two lines are parallel. So we have a condition first. The condition is that these two lines are parallel, therefore A and B are the same. The property is known as corresponding angles parallel lines. In the second case, if the condition, if these two lines are parallel, then angle A plus B equals to 180 degrees. Okay? In the third case, if these two lines are parallel, then angle A and angle B are the same, alternate angles parallel lines. So for these three cases that we are so familiar with, the condition, the very first step is that you're given the two lines are parallel. Then we can conclude something about the angle. Today, in this question, we will have to work backwards, just like the converse of Pythagoras' theorem. Here we have the converse of corresponding angles, or interior angles, or alternate angles. Okay? So let us find some evidence of whether these two lines are parallel or not. I see interior angles over here, 101 and 80. Right? We see the letter U over here. It's kind of upside down. Now, if I add 101 to 80, what do I get? 181. Is that 180? Since it is not 180, what do you conclude about the two lines? They're not parallel. That is how we use this. Okay? So we say that since angle FAB plus angle ABD equals to 101 plus 80 equals to 181 degrees, which is not 180 degrees. Can you follow the argument so far? Since these two are not 180 degrees, therefore, by the converse, or, and we quote whatever we have learned in Sec 1, interior angles parallel lines. By the converse of interior angles parallel lines, interior angles parallel lines, AF is not parallel to BD.
So,
Yes?
I thought like the property of the trapezium, right, is two angle must add up to 180.
Yes?
Then let's say if it's not add up to 180, it's not trapezium.
Yes?
Then you need to be so trapezium.
What are you talking about? What trapezium?
Like that one look like a trapezium, but it's actually not a trapezium.
What do you mean this?
Yeah.
Okay.
Then I say that I added the two angles and it's not it doesn't give me 180, that's why it's not a trapezium.
It doesn't give 180, that's why it's not a trapezium, and therefore?
That's it.
No, then you have to conclude that therefore these two are not parallel lines. In fact, your method is a few more steps more than mine. Why? Because when you talk about a trapezium, you are already making the assumption that there are two pairs of parallel lines. Sorry, one pair of parallel lines. And the fact that you talk about 101 degrees and 80 degrees added up don't give you 180 degrees, you are using the property of interior angle parallel lines. You are falling back to this. Okay? 23. Just want to focus on part D. Which paper was more difficult? Justify your answer. I think you can get some sense of whether papers are difficult or not after your mid-year exams, for example, after your end-of-year exams in the past. When a paper is difficult, we expect the whole cohort to do badly for it, right? When a paper is fair, it's a good paper, we expect a handful of you to do very well, a handful of you to do very badly. We expect the bulk of you to do decent. If the paper is easy, we expect the whole cohort to get 90%. Okay? So, my point over here is that we have to use a measurement to determine which is a more difficult paper. So this is a question of performance. Well, it is definitely not about consistency. It is a question on performance. Therefore, we'll be using the median. Let's find out the median of these two papers. We've got 1,200 students sitting for each paper. So the median position in your cumulative graph will be in the middle. So 600. Draw a line, 600 across, go down. You get two values. The more difficult paper will have a lower median mark. And in this case, that will be our paper 1. So paper 1 is more difficult because it has a median of 20, whatever that is, which is lower than the median for paper 2, which is 30 something marks. Last question. Ali runs at a constant speed from home to a shop. After spending 5 minutes from the shop, if he spends 5 minutes in a shop, his distance from home does not change. You need to understand this vertical axis. It is talking about distance from home. So when time is equal to 0, he is at home. The distance from home is 0. He is at home. As time increases, he gets further and further away from home. Up to 800 meters away. That is where the shop is. So after that, he walks home at a constant speed. He's away for 20 minutes. So we know that at time goes to 20, he must be home already. Complete his journey. So he spent 5 minutes. 5 plus 5 will be 10. So we have a horizontal line over here. Please use a ruler. Then since it is a constant speed home, now speed in our distance time graph is actually the gradient. The gradient of our distance time graph is the speed. It is constant. They are telling us that the gradient is constant. If they tell you that the gradient is constant, they're telling you it is a straight line. Where are the 2 points for the straight line? I put 1 point over here and 1 point back at home. So using a ruler, draw a straight line down. Straight line. Okay. Now, next, part B. Calculate his speed as he runs to the shop, giving an answer in kilometers per hour. So distance, speed is our distance over time. We can use this because it is a constant speed. So the distance traveled 800 meters over 5 minutes. However, they want it in kilometers per hour. So you don't have to be confused about the change in units. All you need to do is to just change the distance from meters to whatever they want, kilometers. So 800 divided by 1000, and we get kilometers. Divided by 5 minutes, change it to hours. 5 divided by 60 in hours. And you get, what do you get? 9.6. Paper 1, question 24. 9.6 kilometers per hour. Next part, part C. Again, you are AMS students, kinematics. You are physics students also. You also have kinematics. EMATS, you also have kinematics. To draw the speed time graph, you have to have a very good understanding of the relationship between the distance time and the speed time graph. So the speed is obtained from the gradient of our distance time graph. So what's the gradient over here? For the first part of the journey, we calculated it was 9.6 kilometers per hour. Okay, so that will be our speed. This is 8, this is 9, and 9.6 will be somewhere here. It is a constant speed for 5 minutes. So draw a horizontal line. Okay, next. He is stationary at the shop for the next 5 minutes. So the gradient over here is 0. It is flat. The next 5 minutes, speed is 0. Do the same calculation for the gradient over here. Okay, you will notice that the gradient is negative. In fact, it is negative 4.8 gradient because the negative 4.8. The units will be kilometers per hour. So this means that he is going in the other direction. This gradient refers to our velocity, but they want speed. So we just take the magnitude of 4.8 kilometers per hour. 4.8. This is 4.8. And that's it. Okay? I have a question for you. What is the relationship between the area under this graph and the area under this graph? What's the relationship? Yeah. The area is the same. Because he traveled to the shop in the first part,